Hello students, today we are going to revise chapter number 7 of physics class 7, that is electricity and magnetism. We are going to start from the topic sources of electricity. First of all, here we are learning about electric cell as a source of electricity. So cell has metal rods which is called electrodes and the chemical substance which is called electrolyte. Inside the cell, there are chemical reactions wherein the chemical energy is converted into electrical energy. So children, here you have a dry cell. This is a figure for dry cell. This dry cell is having a zinc container. Inside that you have a carbon rod. Carbon rod, which is an electrode. This carbon rod is surrounded by a mixture of manganese dioxide and charcoal. And again, the electrolyte here is ammonium chloride. This cell is having two terminals, one positive and one negative terminal. When the cell is connected to a bulb, the chemical reactions inside the cell takes place and the current flows from the anode to the cathode. Okay, that is from the positive to the negative terminal. Now, some of the advantages of this dry cell are given here. Why we prefer dry cell? The reason are, number one, they are lightweight, very less in weight, small in size, portable, that is, it can be carried very easily from one place to another, and there is no fear of leakage. This is the reason why the cell is used in many appliances like radio, calculator, wristwatches, etc. When group of cells, when you connect two or more cells, then it is called a battery. As you can see in this diagram, see, 4 cells are connected to each other and it forms a battery. While connecting the cells, one thing you have to keep in mind that positive of a cell should be connected to the negative of another cell. Just you can see here, positive of one cell is connected with the negative of another cell. And ultimately, it is connected to a bulb over here. Again, when the bulb is connected, it should be checked that one positive and one negative and are connected to the bulb. Once the circuit is complete, electricity will flow and the bulb will glow. So again, I am repeating, a group of cells is called a battery. The next few sources of electricity we are going to see, the number one is mains. Mains means at home, the electric supply to our gadgets like fan, refrigerator, etc. are given through the mains. It is where the electric meter is connected. The meter counts our usage, how much electricity we are consuming. And from there comes the main supply to our house and it is known as mains. The another source is generator. That is, whenever there is a shortage or there is a electricity cut, at that time we use generator. So inside generator, the mechanical energy is converted into electrical energy and we can use that energy. And the last source we are going to discuss is solar cells. That is, light energy from the sun can be converted into electrical energy by using solar cells, and this is a source of energy which is used in satellites. So children, we have now discussed 4 different sources of electricity, starting with cell, then we have the mains, then we have the generator, and finally the solar cells. Now we will go to the next topic, that is the flow of electricity in a circuit. So first of all, what is a circuit? So the answer is the path along which the electricity flows, that is called the circuit. Now let us understand this in detail. Just look at this figure which is given. In this figure, you can see that a bulb is connected to a cell. This bulb is connected to the cell, and once the circuit is complete, the bulb will glow. It is connected to the positive and the negative terminal, and the bulb will glow. The circuit is complete, the circuit is closed, and so the bulb will glow. Now, look at the next figure. Here you can see that the circuit is broken, and so the bulb will not glow. So the main condition for the electricity to flow is that the circuit should be closed or complete. If it is broken or if it is incomplete, then electricity does not flow through it. Electricity flows only when the circuit is complete. Okay. Now next, let us see or talk about conductors and insulators. So conductors are those material that allow current to pass through it. Like you have different metals like copper, aluminum, steel. They all are conductors because they allow the electricity to pass through it. And the materials which does not allow the electricity to pass, they are known as insulators. For example, plastic, rubber, glass, etc. So one of the main conditions for the circuit to be complete is that all its parts should be a conductor. When all the parts are of conductor type, then only current will pass through the circuit. Okay, so the next is flow of charges. Children, we already know that suppose we are keeping two bodies, one at high temperature and one at low temperature in contact. The flow of heat is always from high to low. Same way, when you keep two charged conductors together in contact, the flow of conductor will be from the one which is having more electrons to the conductor which is having less electrons. The electrons or the charge will flow from more to less. Okay, now let us understand this by few examples. Like this first example you see here, there is a positively charged conductor. See, this is a positively charged conductor which is connected to an uncharged conductor. A is positively charged and B is uncharged. One thing you should keep in mind that positive means it is deficit of electrons. The electrons are less here. So you can see the movement of electron. You see the movement of electron will be from B to A. Why? I'm repeating once again. Why? Because this is positively charged. Positive means it is deficit of electrons or there are less electrons here. So the charge is from here or the moment of charge is from B to A. Now let us take another example. See, here you have a negatively charged body A connected to a uncharged body B. Now again, remember, negatively charged means excess of electrons. Here the electrons are excess in this body A. So you can see the moment of electrons will be from A to B. That is from more to less. Let us take one more example. See, here you have two bodies, A which is positively charged and B which is negatively charged. Positive means less electrons, negative means more electrons. And so the movement of electrons will be from B to A. That is from more to less. So by looking at all the three examples, we can conclude that it is always from more to less. The electrons move from the conductor where there are more electrons to the conductor which are having less electrons. Now, based on this, let us give a definition to the current. What is current? So current can be defined as the rate of flow of charge. Or I can say how much charge is passed in a particular time period, say 1 second. So current is the rate of flow of charge. It is measured in the unit ampere. The symbol is A after the name of the scientist, Ampere. Next, let us see some of the symbols and functions of various components of an electric circuit. First of all, we have cell or a battery. So you already know, children, cell and battery. What is the difference? Battery is a group of cells. So as you can see here, see, look at this figure. This is the symbol for a cell. Whenever you want to show a cell in a circuit, you don't draw it like this. This is not the way you will draw. It is drawn like this, two unequal lines. The smaller lines shows the negative terminal and the bigger line shows the positive terminal. Now, this is a symbol for a cell. The same cell, multiple cells if you are connecting, so it will become battery. So here you see, this is a symbol for battery. This means multiple cells are there. And again, see once again, all the positive and negative, how they are connected. Positive of one is connected with the negative of another. Every time you connect a cell, this should be in your mind that positive of one should be connected to the negative of another cell. So this is a series connection, as you can see. This is how you can connect three cells in series. Now next is parallel. Suppose you are having parallel connections. Then this is how you have to draw it. This is a symbol for a parallel connection. Okay. Next component which we are going to see is a switch or key. Means you already know what is the purpose of switch, to on and off. The same way the switch or key is used to put the circuit on and off. Now this is a figure for key. This is an open key and this is a closed key. Closed key means what? The circuit is complete, current will flow through it. And open key means that the circuit is incomplete and current will not flow through it. Now next, this is how you will show a switch. This is a open switch and this is a closed switch. Again, closed switch means circuit is complete, electricity will flow, and open switch means it is incomplete and electricity will not flow. The next component is a bulb or the resistor. Bulb or the resistor, they are the components which oppose the flow of current in the circuit, or we can say a bulb uses the current in the circuit, and a resistor is something which increases or decreases the flow of current in the circuit. So this is the symbol for bulb. As you can see, this is how bulb shown, and this is how a resistor is shown in the circuit. And lastly, we have connecting wires. A simple line, a line in a circuit shows that it is connected or all the components are connected with the wire. So 4 symbols we have discussed right now. Number 1 was for cell. So cell, how it is done. Number 2, we have seen for switch or key. Number 3, we have bulb or resistors. And number 4, we have connecting wires. So 4 components, their symbols and their functions we have seen. Next, we have to discuss about series and parallel. How series connection works, how parallel connection works. So see children, here you have a diagram. See, bulbs are connected one after the another. They are in series. The connection is said to be in series, one after the other. But there is a drawback for this. See, even if one bulb does not glow or it does not work, it will affect the remaining 2 bulbs. In series connection, if one bulb does not work, it will affect the other 2 because they are connected one after the another. They are dependent on one another. Okay, so this is a drawback of series connection. So next, let us see parallel connection. In parallel, all the appliances work independently. They are not dependent on each other. Even if one bulb does not glow, it will not affect the remaining 2 bulbs. And this is the reason why we use parallel connection in our home. In our home, even if one bulb is not working, the others are working. They have independent switch. They work independently. They are not dependent. So in-house, we have parallel connection and not series connection. So We learned about series and parallel circuit. I hope you are clear what is the difference between both. And finally, we will now see some of the precautions to be taken before the circuit is switched on. Imagine you have connected all the components in the circuit. Now you have to switch it on. So what are the precautions should be done for before switching on the circuit? So some of the precautions are: number one, all the components should be properly connected, meaning there should be no leakage of current. Number two, the connecting wire should be tightly connected to each appliances. Every appliance should be connected tightly. Next, do not touch the switch or any component with wet hands. And finally, see that the sources of electricity is properly joined. So these are few precautions which should be taken before switching on the current circuit. Okay, so now we have revised the chapter. Next, let us see some questions based on the chapter just to check whether your understanding is clear or not. So children, here I have 4 different diagrams on the screen which shows circuit, that is a bulb is connected to a cell. Now in this particular first A part, see, you have a copper wire and an aluminum wire. In the B, you have a silk and a copper wire. In C, you have 2 silk wires. And in D, you have 2 copper wires. Okay. And my question is, out of all this A, B, C, and D, in which case the bulb will glow? Cell is there, bulb is there, and they are connected with the help of different kinds of wire, that is copper, aluminum, and silk. So out of this A, B, C, and D, which bulb will glow? Okay, so the answer for this is that bulb D. The answer is D. Why the D part bulb will glow? The reason is because copper is the best conductor of electricity. Silk is not at all a conductor of electricity. Aluminum is a conductor, but not a very good conductor. So we can see that the bulb in the figure D is definitely going to glow. Okay. Next, we have a question, that is, draw a circuit diagram for a bulb connected to a cell with a switch. And you have to also mark arrow to indicate the direction of the flow of current. So see children, so this is how our circuit will look like. See, we have a bulb connected to a cell, and there is a switch also, and the arrow, see, the arrow shows this arrow from the positive to the negative. We know that the movement of electrons or the current will flow always from the positive to the negative. So this is the diagram showing the bulb connected to a cell with a switch, and the arrow indicates the flow of current. Okay, and the last question which we are going to have is, in which arrangement are the appliances connected in the electric circuit? Give reason for your answer. Usually at home, how are the appliances connected? That is the question. So for this, our answer is in parallel. And we already have seen the reason why in parallel, because there the appliances work independently. No appliance is dependent on other one. So even if one doesn't work, the other will work. So at home, appliances are connected parallel. So that's it. We are stopping now. The revision is over.